In this video, we're going to review the concept of compounds because the big part of grade 10 chemistry is about understanding what a compound is and about how to name compounds. So in general, a compound just means two or more different elements, so that's important, different elements, connected together by a chemical bond. And the chemical bond is usually formed by electrons. And it's specifically the outermost electrons, which you might remember as valence electrons. Valence electrons. And there's two types of compounds that you might see. You might see what's called ionic compounds, or you might see covalent compounds, sometimes also called molecular. Ionic compounds, what's interesting about them is that they always form, or usually form, between a metal and a nonmetal. So if you see a metal and a nonmetal, your compound is ionic. And we say it's formed by the transfer of electrons. So if you look over here, this is the metal sodium, and this is a nonmetal chlorine. Sodium is losing its electron, it's going to chlorine. And sodium will now have a charge of +1 because it lost one electron. So you'll learn more about that. You've learned about that when you saw ions, whereas chlorine now has a charge of -1 because it gained an electron. And now they are attracted to each other. And they're attracted to each other because they have opposite charges. So forming by transfer electrons, that's really the ionic bond. That's where the bond or attraction is because of the opposite charges caused by that transfer of electrons. And ionic compounds, again formed by metal and nonmetal, transferring electrons from one to another, they exist as crystal structures called crystal lattices. They don't exist as individual molecules. So this NaCl over here, this sodium chloride structure, is actually more a crystal structure. You have one chlorine for every one sodium, one chlorine for every one sodium, one chlorine for every one sodium. So they actually exist as these big crystal structures called crystal lattices, and they don't exist as one single NaCl structure. It's crystal lattice structures. You'll have to remember metals and nonmetals because that's how you tell what type of compound you have. Remember in your periodic table, here we have a color code. You don't always get this color-coded periodic table, but over here along the staircase area, you have the metalloids. And then to the left of the metalloids, you have your metals, all the blue here, and to the right, you have your nonmetals. There's one exception. The hydrogen is considered a nonmetal, even though it's on the left side, but sometimes it acts like a metal the way it reacts, so that's why it's on the left side, and there's a few other reasons for that. So you do need to remember and review your metals, nonmetals, and metalloids. You'll always have access to a periodic table. What I recommend is you remember where the metalloids are. Anything to the left is metal, anything to the right is nonmetal. So let's go back here. Our next type of compound is the molecular or the covalent compound. This forms with nonmetals only, so two or more different nonmetals. And they don't form by transfer of electrons, they form by share of electrons, and that's called a covalent bond. So here you can see we have oxygen and we have hydrogens, two nonmetals. And what happens is the oxygen will share electrons with hydrogen, and hydrogen will do the same thing. Same thing over here until they're both happy and they both have their complete valence shell. So oxygen has 1, 2, 3, 4, 5, 6 of its own, plus sharing one with here, and this hydrogen makes 8. Hydrogen has one of its own, plus sharing one with oxygen makes it 2, so it's happy because it only has one shell, and that complete shell is 2. Same thing for this hydrogen here. So nonmetals, because they have a similar strength in the way they attract electrons, they're not going to rip electrons away from each other, they're going to share. Whereas when you have metals and nonmetals together, they have very different strength. Nonmetals pull away the electrons from the metal, and that's why there's a complete transfer and ions form. So for ionic compounds, you actually have ions that form because electrons are transferred. But for molecular covalent compounds, think covalent cooperation sharing, there's no ions formed. No one is charged or angry in the end because they're simply sharing. Now, that was the difference between ionic and molecular compounds. It's important that there's two or more different elements. The example for the ionic compound shown here was NaCl because it's a metal and nonmetal. And the example for the covalent or molecular compound here is H2O because it's two or more different nonmetals. So let's try this problem out here. You can pause the video and try it out. You'll notice here that H2 is not a compound. It's interesting because it's two elements connected together. It's actually sharing. There's a share of electrons happening here. They're sharing electrons. But why is this not considered a compound? So if you pause the video and you're checking now, you've probably looked at the definition of a compound. Definition of a compound is different elements. This is two of the same element. So it's not a compound. We would call this a molecular element. So it's two nonmetals but two of the same. So that's why we call it a molecular element. But it's not considered a compound. So keep that in mind. It's an important distinction between a molecule that's a molecular element and a molecule that's a compound, a molecular compound. Okay, so that was a difference in terms of formulas, composition, but there's also differences in properties. So if you analyze ionic and molecular compounds, they have different properties in terms of melting points, conductivity, state at room temperature, and solubility, and that's actually how you could tell them apart. So if I had a compound and I didn't know what it was, I could do different tests to see if it's ionic or molecular. Melting points for ionic compounds are usually pretty high. And here they're usually lower for molecular compounds. That's because ionic compounds have charges, so it's harder to melt them because they attract to each other more. Ionic compounds, they conduct electricity when dissolved. So they do conduct electricity, and even when they're melted. Molecular compounds, when you dissolve them, they do not conduct electricity. Because they don't have ions, they don't have charges. Usually ionic compounds are soluble, but they don't always have to be. And molecular compounds can also be soluble. But again, not always. So if you're doing a test to try to figure out if your compound is ionic or molecular, if you put them in water and that compound dissolves, you can't tell if it's ionic or molecular just because it dissolved, because some molecular could dissolve, they're soluble, and so could some ionic. So you'd have to do more tests. For example, I could stick a light bulb in here and see if it glows. If it glows, that means that it conducted electricity. So that means that it must have been ionic. If it doesn't, then it did not conduct, so it must have been molecular. So usually you need sort of two tests to tell if you have a molecular or ionic compound. You could also test their melting point. So if it takes a very high temperature to melt it, it might be ionic. And if it melts at low temperatures, it's probably molecular. But usually you want to have at least two tests to kind of confirm that it's ionic. In terms of room temperature, ionic compounds are usually solid at room temperature. Whereas for molecular compounds, some are solid, some are gas, or some are liquid, and some are gas. So for example, sugar is molecular, it's a solid at room temperature. Water is molecular, it's a liquid at room temperature. Carbon dioxide, you breathe it out, it's molecular, nonmetals, nonmetals, nonmetals. Carbon dioxide is a gas at room temperature, so it varies more. But ionic compounds, because they have such strong charges, and because they have such high melting points, at room temperature they're going to be solid. You're not going to have gas salt at the temperature of your room. So, in this video we saw what compounds are, that there's two types. We saw how they differ in terms of composition and formation. So metal, non-metals only, transfer versus share. We also saw that they have different properties that you could use in the lab to distinguish between the two. In the next video, you're going to take up the questions here and here. So try these questions out. In the next video, you'll see an answer key, a video key, to make sure you understand the concepts.